everybody. Thanks so much for being here today. It's so great to be in person with everybody here at AWE, and this is amazing. We have a packed house. Great, so today we're gonna be talking a little bit about new applications for hand tracking in VR. We'll go over some of the basics of hand tracking, a little bit about some of the new use cases that we're excited that we are able to unlock now, and some of the technological challenges that our researchers are working on and how we're trying to solve them. But first, we can do a little bit more of an intro. My name is Shannon Hoople, and I'm a product manager at Meta. I've been at Meta for about a year and a half, and I actually started in our rotational product manager program. Started off in Facebook app and really found myself gravitating towards reality labs and our AR, VR experiences. So excited to have found a home here post-program. And Will, would you like to introduce yourself as well?
Hey, I'm Will Najar. I'm also a product manager at Meta, and I work with Shannon on hand tracking. I've done a variety of things. I've done Messenger. Now I work on hands. And I previously worked on HoloLens at Microsoft, if there's any HoloLens folks here.
Awesome. So our team is very much...
Could I interject for just a minute? Everyone, could you scoot toward the middle with the seats? Because we're packed in here, and there's really not even room to come in. So just scoot in so people along the sides, we can fill in and get room for everybody in here.
Thank you.
Sorry.
No, you're all good. Awesome. So our team is focused on new input methods in XR and really believes that hand tracking is an important evolving input modality for XR. So we're really excited to talk more about it. So Will's going to start off with a little bit of an intro about what hand tracking is all about.
All right, let's do it. So what is hand tracking? I hope some people here have tried it. Has anyone tried hand tracking on an Oculus Quest 2? Well, all right, that makes me very happy. Cool. So hand tracking allows you to interact in XR with just your hands. So no controllers. And in our case, you don't need any additional hardware. There's some other players out there where you plug in a device, or you wear something on your hand, or you could put like little markers on your hand. But you just put your Quest 2 on, and we can track your hands in front of you. And you can interact in VR in this case, but also possible in AR with just your hands. You could poke a button, you could twist a dial, you could wave to someone. It's pretty cool. So we launched an experimental version in 2019, and it was kind of hidden. It looks like some folks found it, but it was not really baked into the OS. And we just released a major update about 2 months ago that brings some big improvements. We're doing this because we think it's more natural. It's easy to get started. You don't have to learn how to use a controller. If you're not a gamer and you're not familiar with how to use a controller, you just interact like you would in the real world. We're trying to bring this to the front of the stage on Quest devices. This is one of my favorite applications. It'd be really cool if someone from Unplugged was here. I'm not sure. But you can play air guitar on your Quest 2 device. And I was very skeptical that this would work, but I tried it, and it's quite cool. And this is not a technology demo. You can go try this on your Quest 2 device today. Upload VR just wrote a new review for it with our new hand tracking technology, and it's really positive. So don't believe me, though. You can go try it for yourself. This is also a great example of a title that was designed for hands from the start. So we have some other titles that will support hands, but it's fairly obvious they're designed for controllers, and there are different ways you design the experience if you're designing for hands versus controllers. This is a great example of one that is all about hands. All right. How does it work? Magic. Actually, this is the part that I spend the most time on. We use a technique called neural networks. If anyone here is familiar with machine learning, it is the same technique roughly that your Tesla would use to drive itself on a highway. When you opt into hand tracking on your Quest device, we use the cameras that are in the front of the Quest device, and it provides an image of your hand. And it's literally just an image, like if you took your cell phone and took a picture of your hands. We then apply the neural network to that image and many series of images in real time, and we can recreate your hand. There's 25 points in your hand. We recreate all of them. We know where your hand is and whether you're interacting with something. We also have classifiers that let us know if you're doing a gesture like this. We can train many different gestures. And with all of that together, you can interact with just your hands in VR or XR. We just launched a major update as well, Hand Tracking 2.0. I wrote the launch blog for this one. I was really proud of it. There's a lot of new things that you can do with this that were not really possible in past versions of hand tracking. So you can cross your hands over each other. You can clasp them like this, which is a really hard computer vision problem, and we can tell which one's your left and which one's your right. You can also move your hands really fast, and we'll still be able to keep track of them. So that's a nice segue into Shannon. I'm going to let her take it away on fitness.
Awesome. So yeah, Will shared a little bit about how some of our new technology kind of enables some new use cases. And so we wanted to give kind of a case study of a new use case that we think hands is a really great fit for and that we'd love to see a little bit more coming from developers with, and we think there's a lot of possibilities in this space. So obviously, if you think back to the beginning of the pandemic, a lot of things shifted for everyone, and one thing that changed was the way that we all thought about fitness. Without access to gyms, people had to get really creative about the way that they thought about staying fit and getting exercise, and tons of people turned to VR fitness. I'm sure some of you in the room, myself included. So we're really, really excited about this use case and think it has a lot of opportunity for hands as well and hand tracking. So yeah, we can chat a little bit more about that. So we feel that fitness in VR is an emerging category that can be really well served by hand tracking. But some of the reasons to be excited about it are, one, VR fitness is really retentive. We find that users who build routines in VR actually stay consistent, and that consistency really pays off because VR fitness actually works for these consistent users. Consistent users report real physical change, whether that's weight loss, to improve mental health when they're incorporating a VR fitness routine. So it's a really exciting space. And lastly, Will touched a little bit earlier about how control-less experiences can increase diversity of users because you don't have that additional barrier to entry. If you're not familiar with using a controller, you're not as comfortable with one. And fitness kind of does something similar in that it encourages a more diverse audience. So compared to gaming, for example, in other categories, there are a lot more female users for fitness, and we think the combination of hands, the most natural input method that exists, and fitness could be a real game changer for VR and making the metaverse and fitness accessible to everyone. So it's a really exciting space to be in. We also wanted to highlight another developer who's really doing this right. Lightboxer is an example of one of the first deliberate fast motion fitness apps that we've had that includes hand tracking. And we'll talk a little bit more about what deliberate and fast motion means, but for this time, Lightboxer is a gamified boxing game, and it includes punch tracks and trainers and gives you the opportunity to box in the most natural method possible, which is just with your hands. Obviously, boxing's a really, really great example of a great use case for hands because you can use a much more pure shadow boxing type of style and experience. You may believe it or not, I know I don't look like a boxer, but I do box occasionally. I have my own gloves, I promise. And I can promise that this is a pretty cool experience, and you can really you practice your form in a way that you wouldn't normally be able to do with controllers in the way. Some other cool things about using hands with fitness for a fast motion like this is that it gives users the opportunity to increase their workout difficulty with weighted objects. So you can hold a really light weight, for example. It can make it a little bit more challenging, but you'll still be able to increase the difficulty of your workout. The team worked really closely with ours when implementing hand tracking because, as we talked about, this really started off as something pretty experimental, and now we've launched this great update, but we're still working very closely with developers to implement this in the best way possible. So they also worked closely with us to make sure that the entire UI was seamless, not just the game experience itself of boxing and keeping fit, but also going through the whole UI, the touch and scroll motions that need you to get to that particular point. So again, really great example of a title that's doing fitness right and a team that we worked with pretty closely. So this is just a quote from the CEO of Lightboxer, Jeff Morin, and a lot of the things that I just shared already, but I'll also highlight that he mentions that control-less workouts also allow you to expand to other workout modalities in the near future. So it gives a lot of flexibility for developers. When you take away hands, there are so many more opportunities in terms of what you can achieve. So I mentioned before that Lightboxer is a great example of deliberate, fast-moving fitness. But first of all, what does that even mean? Second of all, what does that mean in terms of how we're thinking about the VR landscape for fitness? And third, what does that mean in terms of opportunities for developers? So I'll start with, we categorize the fitness landscape in kind of two key components. The first one is about the intention behind action. I'll start with deliberate, kind of on this x-axis here. So a deliberate fitness game is one where we describe that allows you to deliberately set and attain fitness goals. So this means that there's deliberate fitness specific features involved, like trackable progress or trainers. And it really means that you're there specifically for a workout, and everyone who's logging in is there for a workout. Lightboxer is a great example, like I mentioned before, but there are a few other successful apps in this space. Many of them don't use hands yet, so like Supernatural, for example, FedXR, great examples of deliberate fitness. If you move to the other side, we have incidental fitness. This is where the primary goal isn't necessarily to get fit, but you're still getting your heart rate up. So there's lots of popular rhythm games that we think fall really well into this category. Beat Saber, obviously extremely popular. Synth Riders, Pistol Whip, a lot of those in those spaces all is what we would consider to be incidental. The other side of this matrix on the y-axis is fast-moving versus slow-moving, so the speed of movement. We mentioned before that our previous technology really wasn't quite there to actually support fast-moving fitness up until really recently. So we didn't have the capacity to support fast-moving fitness for quite a while until recently. We do have an example of a slow-moving fitness that is pretty successful, although there's very few examples of slow-moving applications in this space. That'd be guided Tai Chi. It's basically like encourages slow and meditative movements. So that's one good example, but besides that, you can see they're all pretty much clustered into that fast-moving category, whether it's intentionally trying to get your heart rate up or it's more deliberate. So what does this mean in terms of how we're thinking about this space moving forward in XR? Basically, we want to make sure that we're prioritizing technical improvements in areas where both developers are excited as well as users are excited. And what we're finding is that a lot of those are in that fast-moving space. So moving forward, you can expect a lot of improvements in the fast-moving category so that we can better support fast motion, because that's where we're seeing interest. The nice thing, too, is that if we focus our efforts in that area, we're probably also going to see a lot of benefits in the slow-moving space, too, because a lot of those ML improvements will trickle down to slower movement, right, as well. As we improve latency, you'll see that in the slow motion, too. Whoops. Cool. So another thing to chat about is that fitness applications bring some really unique technology challenges that we see for a lot of different use cases, but a lot more so within fitness. It's kind of like, it's a lot more within fitness. So one example goes back to when Will was describing how hand tracking works. We talked about how we have this computer vision approach using external cameras on the Oculus device that allows you to see your hands in real time and turn them into VR. So the problem with this computer vision approach is that it does rely on the field of view of the cameras. So for something like boxing, that's really not a problem because most of the time you're going to be pretty squarely in the field of view of what's in front of you, right? You're boxing what's in front of you. But for other use cases, for example, if your hands are going behind you, if they're going way off to the side, there's a chance that our cameras aren't going to catch that whole field of view quite yet. So right now, in terms of mitigations, we do encourage that the best hands candidates, or if you're thinking of building for hands in the future, that you make sure that your hands are pretty squarely in field of view for the majority of the game. We can sort of compensate for that. Our models do have ways to sort of predict where your hands are going, but we don't want them outside of the field of view for too long. Otherwise, it's pretty likely that we'll lose track at some point. So that's in the short term. But in the long term, we have a lot of solutions that we're exploring. One, there's opportunity for hardware improvements. There's also opportunity for supplementary hardware. The challenge with that is adoption friction, right? Having somebody buy an extra accessory or extra hardware, there's always going to be some friction with that. And kind of the idea behind hands is that it's the most natural input method ever, right? You shouldn't need anything extra, hypothetically. So that's a trade-off that our teams are considering, but it's one that we're certainly thinking about. Another challenge that comes up with fitness applications is what we call optimizing for course tracking versus fine dexterity. So when you're playing these fast motion games that we were talking about earlier, let's say you're playing Beat Saber or something similar, we're really only concerned with where your wrist movement or major hand movement is going, right? We don't really care what your fingers are doing. That's a lot less important. But it's really important what your fingers are doing for a lot of other use cases. So for productivity, for media, we care a lot about if your fingers are pinching, if they're pushing a button, if they're raycasting. That's all super crucial, right? So what does that mean for our team? We have to think about how to optimize for these different use cases. Is there a way that we can make trade-offs in our machine learning models to emphasize specific types of experiences? Can we give that to developers so they can focus on building for fitness and we're making trade-offs in CPU so that there's less latency, for example? There's a lot of things we can do and that our teams are thinking about as we understand where developers' interest lies and what types of things that you want to create. And then lastly, especially for more intense users for fitness, most people are not going to want to just stop at body weight, right? So we have to think about more immersive interactions with physical objects, whether that's weights or a bike, for example. We could have a stationary bike like your Peloton. We can have weights or small kettlebells. Right now, we don't necessarily support using anything outside of hands, but that's something that our teams are thinking about, right? We could use similar techniques in machine learning for body tracking, for example, for tracking something like a small weight or kettlebell. These are all opportunities that we're thinking about. There's also safety challenges in the fitness space. Obviously, you want to be careful about where you're swinging weights around when you have a headset on. But they're all things that we're considering, right? Awesome. So now that you've had an understanding of what we're focusing on, what hand tracking is, some of these new applications, and some of the technology challenges we're thinking about, we can talk a little bit about what's next. What does that mean for developers? Where can you step in? What are we thinking about for the future? So our goal is to make it as easy as possible for developers, both for new apps as well as integrating existing apps to use hand tracking. And there's a couple ways that we're thinking about doing this. One, we're really, really focused on doing as much as we can to source developer feedback to optimize both for fitness use cases, but really any use case. It's important that in order to get the technology to where we want it to be for you guys, we understand what you're excited about building. We've done a pretty good job of this with 1.0 and especially for this 2.0 launch of trying to understand what devs are excited about. We can always do a better job. We always want to hear your feedback about what you're excited about building. And we used fitness as an example, but this really counts for any use case. We want to know what you're excited about. Secondly, it's really crucial that we think about growing our hands content ecosystem. There are some really great examples of hands content out there. We highlighted some of them, but there's a lot more that could potentially come, right? And we want to make sure that it's easy for users to understand or to be able to experience like effective, easy to use, natural hand tracking experiences so that they seek them out and say, hey, I want to use hands, right? This is better than controllers. That's what we're hoping for. And then third, we can't share too much yet, but we are hoping to introduce a new proof of concept for testing hands so that you as a developer can understand whether or not hands is the right fit for you, whether or not your app might be a good candidate for it in a really easy, lightweight way. Yeah, like I said, we can't share too much on that one yet, but please look out for an announcement from our team later this month on the Oculus developer blog. Would love to share a little bit more then. Cool. So that's our overall presentation. But yeah, we'd love to probably take a few questions if anybody's interested.
We got about 5 minutes left. Just go ahead and step up to the mic, actually.
I've got a fast, easy one.
Go for it.
Can you do impact estimation as well for how hard you hit something, whether that's hand on hand or hand on head or hand on punching bag?
Yes, we can do that. It's not in our production API, but it is possible. That would be a great example where if you're really interested in this, another one we hear a lot about is calorie counting. come talk to us about that so we can hear from you and prioritize that. Go ahead.
Hey, so I have a question about how you train your ML models. Do you use real data or synthetic data or both?
You want me to answer it?
Yeah, I can share a little bit. Yeah, so we collect a lot of our data in labs, basically, where we're taking images of thousands of different hands. So, but it's mostly lab data.
We do use both, but we do a lot of data collection. If you work in the ML space, like data collection can many times be the hardest thing to solve. We collect a lot of data in hands, like different skin tones, different orientations. One interaction we do is poke, and people just poke in different ways. So we need to expose our network to a lot of different types of pokes so we can handle them all gracefully. So yeah, the answer is both.
Talking about limitations on the hands, like for somebody who has a disability or injury, how well it captures a hand, what defines a hand?
Yeah, so that's tricky. So what we're doing with our approach is we're trying to train a computer to understand, like, this is a hand. In every frame, we're saying, is there a hand? Is there a hand? And in order for it to recognize many different hand combinations, basically just needs to be in the training set. So we can recognize some. I would encourage you to go try it. And if it doesn't work for you, please tell us about it so we can cover that scenario more gracefully. This also comes up for people who have like the typical hand that looks like mine. But let's say I injured my finger and I put a Band-Aid on. That's actually
splint.
Yeah, so Shannon's
It does work, but
that's a great example because our system is like, is that a hand? Because there's something else that I don't usually see. Should I treat that as a hand? So as long as we capture it in the training set, we can do fairly well with those. Please go try it. If there's something we haven't seen, we would love to make sure we can support it. Accessibility is really important.
Hi, I have a question about the sort of what you're proud of the most and why. So in your hand tracking, I've tried it and it's pretty good, but for you as the people developing it, what aspect and feature are you the most proud of and why?
yeah, we can both go. But yeah, for me, because I've been really focused on the fitness space, the difference, if you guys haven't tried it, between the experimental tracking and the new one for fast motion and latency is crazy. Like, the improvements are awesome. Like, we can finally support fast motion in a way that we absolutely could not have before. So that's what I've been most excited about, is our reduction in like latency and jitter when we're dealing with like faster motion scenarios.
And might I add, why do you, so is it from your personal background in fitness that you think this, like you see that how important fast movement can be?
Yeah, I think that's the primary reason. And
Yeah.
also I've been able to, obviously behind the scenes working with our research scientists, I've seen that this is a tricky issue to solve.
Right.
So I'm just very proud and excited
Awesome.
that we've gotten to the point where we're solving it. Yeah, thank you.
Really cool.
I would say the thing that excites me the most is when people try it and realize like actually how well it works. I was a hater. I worked in a different space, and someone I'd worked with previously was like, yeah, come work on this team with me. And I was like, yeah, right. That doesn't sound real. And then I tried it, and it works really well. And this new version we've just launched, 2.0, I'm really, really proud of that. It works quite well. I think we're at the point where the machine learning and computer vision approach is no longer the limiting factor to develop like kind of an everyday hand tracking solution. Now some of the challenges are like the user interfaces and how we would design a title so it's ergonomic and comfortable to use with hands.
And I must add, I'm sorry, but do you feel like we're reaching like the end of, or not the end, but the sort of tapering point of hand tracking development, or do you think it's?
I mean, that's what we're doing. So hopefully we're successful. That is what we're aiming for. We're aiming to the point where you could use an XR device with only your hands. You never need to interact with a controller.
Okay, cool. Thank you very much. Thanks.
Piggybacking on what he just said, I'm aware of the Control Labs acquisition by Facebook and Meta and using EMG around here, which solves many of the problems such as occlusion and also positioning of the hands with an IMU and cheaper sensors. And it could be cheaper than doing computer vision on the device. Why are y'all still pursuing this even with a multi-million-dollar acquisition of Control Labs, and what's the status of that project in breaking down these barriers?
Yeah, cool.
I was actually expecting y'all to talk about Control Labs in this talk.
Oh, okay, gotcha. Yeah, so because we're focusing on VR, we talked a little bit about how there's a little bit of adoption challenges when you add additional hardware, right? We think it kind of goes against, at least for now, the antithesis of what this is all about, which is for everyday consumers, like you should be able to experience this right away without additional hardware. So I think like it just kind of goes against what we're trying to do right now. But if you want to chat more about Control Labs.
I'll just add that like our vision is to make it really easy and accessible, so that having to add additional cost, hardware, a learning curve like kind of goes against that. However, there are examples where someone can say, hey, I'm fine with that. I like this enough that I want to go buy that hardware. We want to give people options. So there may not just be one way to solve this. We want to give people an option to pursue whatever gives them the best experience. So I actually don't know a lot about what we're doing there. But I would not say that, because we're pursuing this, we're not pursuing that. Like we're pursuing actually many different options. And what you saw here is one that we really believe in, but not the only one.
Sure, yeah.
Hi, thanks for the talk. It was awesome. I am here acting as chief marketing officer for Fingergun, a built for hand tracking experience on Oculus. Yeah,
Amazing.
And we're actually announcing a launch date this month. But my question would be, do you have any advice for somebody like me that is presenting this to folks, without a controller, and any tips for marketing and kind of showcasing that without the mixed reality, showing the hand controllers and kind of that feeling of what it's like? And yes, I would love to hear what you think about Fingergun.
That's a great question. I think you should email us because we want to highlight you in the Oculus store. We're doing a showcase of developers who've built great hands titles because we want to tell people about what we can do. So please email us. I would also say, highlight how intuitive it is, highlight that that it's very accessible, and it can be more comfortable. You don't have to hold the controller the whole time. I'd also recommend looking at what some of the other developers have done. There's a great hands developer community. They're all very friendly. I'm sure they'd be willing to chat with you, like, hey, this worked really well for me. Like a lot of people are excited. Tap into the community.
Awesome. Thank you so much.
If you have additional questions,
Yeah, you can come
we
chat with us
stand
later
outside
too.
and you can ask us.
I have one because we were on your presentation actually. So
Oh, amazing.
I'm Alex from VR Workout. I think we are the leading hands tracking implementer to date. And I just wanted to ask, why did you put us in, deliberate was very accurate, but why did you put us in slower moving from the grid? I think you need to try hard mode to see how fast we go.
Thank you for calling me out. I think the reason that we put you a little bit low, we didn't put you in slow moving.
It's like on the slowest.
It's a little bit compared to boxing when you're going like so fast.
This is all Shannon, by the way.
Fine. Thank you for.
But I did put you in slow moving.
Thank you for mentioning us.
Okay, thank you. Yes, we can chat in the hall. Thanks, everybody.